Hi everyone, my name is Thomas Kim. Today is June 3rd, 2019. This is my 26th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about STD shared PTR or STD weak PTR. STD shared PTR is used together with STD weak PTR. STD shared PTR was first introduced to C++ 11 standard, and it will be significantly improved in C++ 2A standard. If you click this button, you can read more about shared PTR. It was first introduced in C++ 11. And shared PTR will be greatly improved in C++ 20. Okay, in C++ 20, shared PTR will greatly improved. For example, make shared in C++ 20 standard. It will also support array. See array size to use. So in C++ 20 standard, we can also create array type of shared PTR. In C++ 11, T is not array. In C++ 11 standard, we cannot create array type for shared PTR. To follow this episode, please double-click this link and click Show More. Please double-click this link. We will be using some source code from this episode, object slicing problem. Click Show in Folder, unzip it, right-click, rename it, shared PTR 01 solution. Hit enter, cut, paste it to your working folder. Click the solution folder, copy the folder path, start Visual Studio. I'm using Visual Studio 2019. Go to File, Open, Project Solution, paste the folder path, hit enter, then select this solution, Memory Leak Detection Solution. Click Open. If Solution Explorer is not open, go to View, Solution Explorer. You can click this tab button, then it will be fixed. Click Solution, right click, Add New Project, Language C++, Platform, Windows. Here, select Console app, click Next, Shared PTR 01. Click Create. Right-click the project, set as Startup Project. Right-click once again, Properties. Select All Configuration, All Platform. Click C++, General, Additional Include Directory. You can click this button, Edit. Click this button, $solution dir include. Then click OK. Language C++ language standard. Please select 17 standard. Apply. Click OK. We can delete this part and click header file filter. This is called filter. Right click, add existing item, go up, there is include folder, click memory leak detect, add here, include memory. This head file is for shared PTR and weak PTR. Then include memory leak detect. Okay, click this button. Make sure debug build. You can use either x86 or x64. I will use x64 in debug build. You have to select debug build to detect memory leak. I will first talk about dynamic allocation syntax. Void dynamic allocation syntax. Say int iptr new int std cout ptr iptr std and there iptr. I will copy this function, copy, paste, Control F5. So the value of the object iptr pointing to is garbage. The value of the object allocated by operator new is garbage or an initialized value. Now I create another one, int iptr2 new int std cout iptr1 std and there. Now let's run it. Control F5. This is iptr2, Control F5. So it is initialized to 1. Okay, this curly brace is used to initialize allocated object. The value of the object, the pointer iptr2 pointing to is initialized with the value 1. Okay, this is not array. This is not array. This syntax does not allocate array or int. Okay, now let's learn about how to allocate array. Int iptr3, this is array pointer. New int, this is array size. For example, size t, array count, I would set 10. Then this is array count. Okay, we are allocating array 10 array for size ti equals to 0, I less than array count, I plus plus. Now we print out the array like this. std cout iptr3, sorry, I std cout std and there. Control F5. So these are all garbage. Okay, it creates 10 arrays, 10 integers but they are garbage. This syntax allocate array count of elements of type int. The elements are uninitialized. Okay, now here int iptr for new int array count we allocate array count of elements of type int initialized to default value of type int, i.e. 0. Okay, now I copy this part once again, pasted it here. This is 4. Control F5. So it is initialized like this. Of course, we have to delete. After use, delete iptr. Since iptr is not array, this is not array. iptr2 is not array. I fix like this. Then here we have to delete iptr2. Okay, and here this is array. iptr3 is array, so we have to delete like this iptr3. When we delete array, we have to use delete operator. Okay, since iptr4 is also array, we have to delete like this, delete delete iptr4. Now I will include here memlink detect, memlink check, checkpoint like this. Now I will create a block. I created a block like this. Okay, now let's run it. Control F5. So everything works fine. If we forgot to delete, we cannot avoid memory leak. So at line 11 checkpoint 40 bytes leaked. Because integer is 4 bytes, we allocated 10 integer, we haven't released, so 40 bytes leaked. Okay, I will restore it. You should never use this low construct of C++. Never use low pointer like this. Okay, if you ever have to use pointer, then do like this. I copied, pasted. Okay, here the proper way for dynamic allocation syntax. Okay, we don't need this because we will never leak resource. And I will also remove this block. Go up. Now here we actually don't need this. We can just say auto. Okay, then use std make unique. int, it dynamically allocates an initialized value. Now we don't need this. Here also auto iptr2 std make unique int. Now we are initializing with 1. Okay, we don't need delete. Here auto std make unique int. Now we are allocating array. Okay, this is array, this is array count. Okay, we don't need this. Here let's try it. Auto std make unique int array. The first is size, the second is we cannot, in this case we cannot initialize. Let's try. Okay, if it works. Let's try it. No, it doesn't work. In case of an array, we cannot initialize. Okay, then we have to initialize. It is garbage value. We don't need this. This is the proper way. I will copy this. I can delete this. Control F5. So it works properly. By default, it is initialized to 0. Okay, it is initialized to 0. And allocate array of elements. Elements are initialized to 0 or default value. We always should use this syntax in C++. This code is not exception safe. Not exception safe. For more about unique PTR, please click these links. By double-clicking this link, you can learn more about how to use unique PTR. I filmed 1, 2, 3, 4 videos about unique PTR. Now let's move on to shared PTR. I will create a function here, void shared PTR basics. Shared PTR is a pointer, smart pointer, std shared PTR element type is int. Okay, sp1. This sp1 is an initialized unallocated memory. Shared PTR has two pointers. One is pointing to the allocated object of type int in this case. Okay, the other is pointing to a block of memory that has two size T. One is for use count. The other is for week use count. In this case, SP1 has one pointer that is null PTR because we have not allocated any memory for int. SP1 has another pointer pointing to a block of memory that has two member fields. Use count is 0. Week count is 0. I would say week count. Okay? So it is pointing to null PTR. Now we test this SPTR like this. Void get shared PTR. std shared PTR int PTR. We have to regard shared PTR as a pointer, so it can be null if PTR std cout, I would say sptr 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 std and there else std cout sptr is unallocated, uninitialized, or invalid. std and there. Now from here we call this function sp1. Okay, I copy this function and I will print out message here std cout. Wow, not crash it. std and there. Control F5. So SPTR is uninitialized or invalid. Wow, not crash it. Okay. If we don't do this, if we don't check the validity of SPTR, our program crashes. Okay, I will copy it crash. I will remove this part. I will disable like this. If we call this function copied, pasted sp1, it will crash. Okay, it will crash. Now let's build once again. Control F5. It crashed. Okay, this message hasn't displayed. So you have to regard shared PTR as a pointer, the smart version of the pointer, of a pointer. Now I will disable it. Now let's learn how to initialize shared PTR. Void initialize shared PTR. std shared PTR int sp1. Here, this is constructor argument new int. This is an initialized int. Okay. We initialize sp1 with a dynamically allocated int. The int itself is not initialized. Now we display std cout use count of sp1 use count. std cout the value the sp1 the value of the object the sp1 is pointing to. We can access like this: sp1 std and there. Now we create another int std shared PTR int sp2 sp1. We are copying sp1. Both sp1 and sp2 share the allocated int. std cout use count of sp1. Okay. sp1 use count std and std cout use count of sp2 use count std and sp1 use count is equal to sp2 use count. Okay. Now we call this function pasted it here. Now I disable it. Control F5. it is function. Control F5. So here we allocated sp1 with one int. So use count at this point is 1. Okay. Now we created another sp2 shared PTR. We copied means they are sharing. Both sp1 and sp2 share allocated int. And this allocated int is shared twice. Once here, another one's here. So both use count is the same. Use count is 2. Okay. Now I modified the value of sp2. For example, 2. I modified sp2. Now we print out std cout sp1 sp1 std and there. So sp1 sp2 points to the same object. Control F5. So sp1 we increased sp2 here, but the value of sp1 is 2. Both sp1 sp2 points to the same object. This method is not good. This is not exception safe, and I discourage this syntax. I will copy this function once again. Copied and pasted it here. Better way to initialize shared PTR. Instead of doing this, do like this. Auto sp1 std make shared int like this. Okay. Now the value of the object sp1 pointing to is initialized to int default value. So here we can also do like this. I will copy this, paste. This is the same. Okay, this is the same. And here, before C++2A standard std shared PTR does not yet support array semantic. Here, std shared PTR int, this is array, sp array, new int 10 uninitialized int. We will initialize to default value. We allocate 10 ints initialized to int 0. It may work, but it is not yet introduced to C++ standard before C++2A. In C++2A, array is supported for shared PTR. Okay, I will copy this function, copied, and pasted it here, like this. Control F5. Okay, it works. So this value is initialized to 0. Okay, here with this syntax, sp1, the value of sp1 is initialized to 0. Everything works as before. I will copy once again, copy, watch out, move semantic. Okay, everything is the same. At this point, we use std move. std move. I will delete this. After std move sp1, now sp1 is invalid. Okay, it can crash. Let's try it. Okay, it can crash. Let's try it. I will delete this part. I will copy this, paste. I will disable it. This message should be displayed properly, otherwise it's crashed. Control F5. It's crashed. This message is not displayed. Okay, after move, we moved here, Control F5 once again. So use count of sp1 here is 0 after move. And if we try to access here, sp2 we initialize this is causing the problem. Okay, then we can test like this. If sp1 else std cout. Now sp1 is invalid. std and Control F5 once again. Wow, now sp1 is invalid. Wow, not crashed. So this syntax is important. Basically, you have to regard shared pointer ptr as another pointer. In my next episode, I will deal with more advanced technique related to shared ptr. Please subscribe to my YouTube channel. Thank you for watching.